So, like, you go into a company and you all have your own internal words and lingos and abbreviations, and you're searching for tasks or you're searching for documents or you're searching through repos for specific things. That ML, if you have an ML library set up within your company, it'll spit out exactly where it is, what it is, blah, 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 without you having to search hours through documentation or, or spend hours in the Slack channel asking other engineers to ask another. They're selling they've created these templates of containers of ML libraries. So it doesn't have the company's data in the ML library, but it has the framework, and all the company has to do is train their people to input the data.
Get ready to embark on a journey through cloud tech with our extraordinary guest, Demecos Chambers. He is not just a cloud tech architect and cloud tech advocate, but a certified master in Azure and AWS. Demecos brings a wealth of experience in shaping cloud landscapes, currently at the forefront of cloud engineering. Join us as he unravels the secrets of cloud tech, AWS Cloud and Google Cloud. Let's dive into it. Demecos, welcome to the show. How's it going for you?
I'm glad to be here. Here to spread the word as a cloud advocate, and be able to talk to your community and engage and learn from each other. So yeah, thank you for having me.
Great. So, because our viewers might want to know what is the role of a cloud engineer before we dive into anything very specific about cloud engineering. So, if you can please share it with us.
Yeah, so basically, a cloud engineer, they basically implement the architectural designs that a company or organization might have for their cloud infrastructure. That might be in a myriad of facets. It might be a hybrid situation, it might be completely uncloud, might be microservice out, what have you. But a cloud engineer overall knows how to implement the solutions that an architect designs on a company's cloud infrastructure. So that's practically what a cloud engineer is and what they do.
Got it, because so cloud engineers are often seen as trailblazers in the world of technology, and
Yeah.
they play a pivotal role in driving innovation and shaping the future of cloud computing as well, and
Hmm.
making it easier for businesses to adopt and leverage solutions that can be run on cloud, right? So, Dimekos, we will drive our discussion towards a bit of data science, and and data science has been existing for quite some time now,
Yeah.
but the emergence of cloud computers have enabled model deployments, training, and whatnot. Right.
Hmm.
So, as a cloud engineer, how do you see the role of cloud computing when it comes to enabling data science projects and initiatives?
Yeah. Well, I mean, you have this growing niche of uh, uh, cloud data engineers, where they're interacting with cloud technologies, such as Hadoop, various ML libraries. Um, Um, I mean, I think of so many. BigQuery uh, is interacting a lot with SQL. I mean, basically everything that a data scientist would deal with on premise for a company infrastructure, you basically would do the same thing just in the cloud infrastructures for a various cloud vendors. I would say the only thing is with a engineer in today's time who's looking at interacting with the cloud is they should focus on being specifically good at migrating data to a specific vendor first. So those it's always just you have your three main big players, especially here in the States. You have AWS, you have Google Cloud, and you have Azure. So I say always choose one vendor to specialize in migrating data over to first, and migrate. And once you migrate it, um, also learn how to manage that data in the cloud in a cost efficient way. And that's going to give you an advantage going into a lot of companies for interviews, and getting into a lot of newer data roles that are because companies have implemented cloud infrastructure within their tech stack. So it's not, I would say, yeah, it's not that you have to learn a whole entire new language because the data is the same data. It's SQL, it's Java data, it's these ML libraries. They're the same on premise and off premise. You just have to learn how does the cloud interact with that data and how can you optimize the cloud's usage with that data. So that's what I would say. How the data engineers are converging onto cloud technologies.
Hi everyone, thanks for watching the podcast so far. Sorry for the pause, but this video has been powered by Data Science Pathshala. Data Science Pathshala has come up with a mentorship program for aspiring data scientists. So if you are looking for any help regarding data science, kindly do enroll in this program, which includes mock interview, resume preparation, customized path to upskill in data science, and much more. This mentorship program is absolutely free. Kindly fill the Google form in the video description to enroll for the mentorship program. Here are the testaments of some of the people who upskilled themselves at Data Science Pathshala. Got it. So because cloud platforms provide powerful GPUs and parallel processing capabilities nowadays,
Hmm.
which accelerate model training times. And data scientists can experiment with complex models and algorithms without the constraints of having the limited local resources. And
Right.
that being said, if we can dive into cloud technologies like AWS, Azure, and GCP, that's Google Cloud
Yeah.
Platform, and really support the scalability and performance requirements of data intensive applications. So can you please elaborate a bit on that
Yeah.
scalability of
Sure.
models?
I'll dive as deep as I can. I'm not a data scientist, a data guy, but I've collaborated with them quite a bit. So I'll say this: the thing about you the cloud resources that offers the scalability and the flexibility compared to on premise um, is something that gives the cloud advantage because you can scale up so fast with least resources compared to your local servers. Also, one of the things that makes this interesting for a data engineer is that you don't only have to operate on the side of data implementation. Um, you can also dive on the side of data security. And a part of that data security is being a part of disaster recovery efforts, which also the cloud has an advantage of over the local. Because when things go down, you can automatically get an environment back up and running within a matter of minutes if your disaster recovery methods have been implemented correctly, which a data engineer would take part in on the security side. And then you can also do a part of the data security is dealing with IAM permission. So that's allowing who has permission to what, utilizing cloud resources. So I say all that to say, not only does cloud offer the speed, the reliability, and the security that's a lot more optimized than local environment setups. It offers also a variety of opportunities for data engineers to not have to be a SME data engineer of all things data. You can really just be a SME of a specific aspect of data. So rather that's encryption, rather that's again DR methods, rather that's optimizing the data. Like there's so many, you get to play around with this cube in so many facets to where you don't have to get caught up in trying to be a know-it-all when it comes to data. And cloud again not only offers us that opportunity to be able to uh, get the performance that we need for customers and clients. But again, the career opportunities are more expansive, working within data within the cloud. So that would be my take on it.
Got it, got it. So, Demecos, I have been recently working on, as you said, that you have collaborated with data scientists, along with cloud engineers. So, I have been recently working with large language models for a startup, and the biggest issue that we faced recently was the deployment of these, large language models. Now, how cloud engineers handle the deployment and management of the AI/ML models at scale. Now, another big problem was determining how much GPU and CPU is required to scale the model if
Yeah.
you deploy it on an AWS. So how do we gauge that?
How do you engage what the amount of space
Yeah,
on
amount
a
of space, the number of cores of the CPU that's required or the GPUs that is required to.
Yeah, like on AWS. I mean, it's yeah, you know, if you have if the data is already installed on a local server, Basically, what you need to do is find a EC2 server in AWS that has the same attributes, or at least the desired attributes you're looking for. So if you're looking for something with a lot of space, then you need to consider if you need to consider if you need to use. There's different storage families. Which storage family? I forgot which one is best optimized for space, but they all go up to like terabytes in size. And then you also it's all storage based. So if you're looking for a lot of speed, there's a storage family for to help you with your vCPUs, which is your cores. You can change your RAM. I mean, you can do there's some that's optimized just for GUI. There's some that optimized for computing. There's storage families optimized just for storage. And then you also have like file storage servers also to facilitate with transferring data across the network. And then you also have the um, S3 buckets themselves, which are storage facilities. So it's all it's everything you need is there. It's really about finding out what's going to optimize what you already have locally, because what you already have locally is good, but you don't have, due to it being physical, and the physical man labor it takes to continue optimize. You can just find that in the cloud and just optimize it for less, for a portion of the cost. You just need to have I think I was always employ organizations to have skilled engineers, such as cloud engineers or what have you, who can or solutions architect who can talk them through, well, what is feasible and what's going to make sense, because it's not going to make sense for every organization to just go from local servers, and then because the cloud is pretty and new, and you want to hop onto Kubernetes because it's hot. You want to containerize your whole entire environment, and you have to always do things that make sense. But this is why you have cloud experts. Those of us who have studied in the cloud, worked in the cloud, most of us who've got certified in the cloud. So most important, we just have experience doing these things, making sure that you're not just doing things because it's hot and it's new, but it makes sense for the business now and for the future. Being able to optimize those costs. So yeah, I mean, you got everything that you have on premise, you're going to have in the cloud. Everything about a SSD drive, or regular HDD drive, whatever flavor you have on premise, you're going to have in the cloud. Just more optimized, and you can make more specifications to it in a shorter minute, a smaller time, and be able to make that jump immediately. So hopefully that answers your questions a little bit.
Yeah, I got it. Yeah, I got it. Yeah, yeah. So, Demecos, one important thing is, besides data security and data governance, and
Mhm.
compliances are also crucial in such data-related projects, right? Now, how cloud engineers practice, aligning with data governance requirements to ensure, quality and regulatory compliances.
Yeah, so I have experience, like, especially if you're a cloud engineer working for a healthcare company, there's a thing called HIPAA compliance that you have to abide by. So that is all 100% about data security, and there's no grace in encrypting, making sure the data isn't leaked at all to the public. So it's one of those things when, especially when data integrity is a must. This all boils down to the compliance, the strength of the compliance that an organization has, which is basically your security team and SOX team that are part of your compliance. It's really up to them to ensure and enforce that it's being carried out, because your cloud engineers are going to oftentimes abide by whatever like the thing about compliance that makes it so important is it sets the parameter of how the IM roles are to operate within the structure. So it's going to allow and deny you from being able to take certain actions within the cloud structure. So your engineers are only moving within what they're allowed to and to not to do. So it's not like we're going in your environment and bumping around and bumping up servers, exposing IP addresses at will. That's what your IM privileges and conditions are for. based on compliance, saying this is what you can and can't do. These are where servers can be exposed. These are where servers aren't to be exposed to the public, and these are the structure of your subnets, etc. So that's all going to be based upon your security team, security and your compliance team, and they have to have a great relationship with the executives who have to communicate with uh, uh, government standards such as HIPAA. Yeah. So as a cloud engineer, that's one of your least worries is about what you're going to expose, because most times than not, you're not going to have the availability to be able to do so. The capability. But you still need to be cognizant of what the HIPAA laws are, and you need to be cognizant of what data you can and can expose, such as secrets. Like secrets is a big thing within our within companies that have an IAC stack. That's infrastructure as code for people watching. You don't want to put your secrets in your IAC stack, because you have all type of uh, monitoring bugs out there that will scan IAC stacks and pick up secrets. So and it's even worse in Europe. I did some work in Europe where, unlike America, if you in America, if you have a breach, then a company has to deal with it internally. And if they're a private company, they might have to let their investors know. They might choose not. It depends on how the severity of it. But in Europe, when there's any kind of breach, you have to let the entire public know and the government. Like, it's mandatory. So yeah, you just have to, all this is a part of being a professional. Look, it's that look twice before you leap model before deploying any kind of changes to your infrastructure. And so it's always just good to abide by what your IAM privileges are, and then just look over your compliance of what you can and can't do. And are you doing what? Rule of thumb for me is, am I doing work on a public server? If I'm doing work on a public server, I'm always extra cautious of everything I do. But if I'm doing work on a private server and I know that's well secured, I can. There's a little bit more lax there without uh, releasing data to the public. And as a data engineer, that's not something that you all have to necessarily worry about, because you're not actually deploying the changes to the cloud in most cases. You all just are having to make sure that the data is correct, and it's going into the correct buckets or the correct places within their infrastructure. But there's checks and balances everywhere. You're not going to, especially for those newbies and freshers coming in, you're not going to have to worry about coming in and having to be the SME. It's an organization. They have checks and balances throughout the whole entire stack. So that's another benefit of the cloud.
Got it. So, Demecos, cloud providers are actually investing heavily in such security measures, ensuring that the data is meeting, industry-specific compliance requirements. This
Mhm.
gives the organizations, confidence in handling sensitive data in the cloud, right? So, Demecos, you have probably come across some great practices for optimizing cloud infrastructure to handle
Mhm.
large-scale data processing and analytics or data science projects. You know, you care to share some of those?
Yeah, I would say some good practices is um I would say well, for one, is a company that uses IC stacks for their infrastructure. It's just a lot easier to read. It's a lot easier to make changes and configurations to, and it's more transparent across the company. Because anybody can, in a company, especially on the engineering side, the data engineers, cloud engineers, whomever, could easily pull that stack from a repo and see what's there. So that even helps them with versioning. They know what versions of data to use. They know what versions of a server to use that supports the data, et cetera, et cetera. So an IAC stack is always important. So if you're working with a company or going to an organization that doesn't have an IAC, you need to question why and how you can implement one. I would also say optimization, uh, automation tools. Automation tools are usually along the best practices. So things like CI/CD pipeline, like using GitHub or using Bitbucket, and then also using things like Terraform is a great CI deployment tool. Um, anything that automates an engineer from having to manually hand off work to another part of the team or another portion of the development until it gets deployed to the cloud. Anything that automates it is always a part of best practices. And I know most employers are always looking for that when they're interviewing newbies. And then if you're a company itself, you need to have be able to automate tasks. And this doesn't mean that you're eliminating the use of for people to fulfill roles. It's you're giving your people more time to concentrate on things like making better data algorithms or making better IC stacks or better documentation, things that are important to the company versus the manual labor of having to give off the work to the next person to take on, which those tasks should be automated. So automation, and then I would say thirdly I would say is I would say documentation. Um, that's something that gets overlooked so much in most companies. As in, if you're a fresher coming in, a newbie coming into tech, and you notate that you show examples of projects you've worked on and how you document it, that's going to be a huge bonus because most companies are just terrible at documentation. You have engineers who are always coming in and out of the organization, and you have some really good engineers who are leaving, and they're leaving with all the knowledge with them. And that really hurts a company's value internally. So even as an organization, you should practice great documentation. And there's automated tools out there to help with documentation. But yeah, so those are, I would say, the three best practices in optimizing your cloud infrastructure to support your data engineers, off the top of my head.
Got it, Demecos. I have been through that. Yeah, I relate it completely. So, integrating on-premise data systems with
Mhm.
cloud-based platforms can be a bit tricky. Now,
Yeah.
can you talk about the advantages and challenges one can face regarding that?
Yeah, with the different cloud platforms.
Yeah, cloud platforms
Yeah.
being integrated in on-premise data systems.
Yeah. So every so fundamentally, this is especially what I tell freshers, and because I don't know if your audience of news are usually either persons working in tech trying to optimize their infrastructure, or they're people trying to get into tech. So I always try to talk to both, but uh, to benefit both, their cloud itself is fundamentally the same, regardless of the vendor, regardless if it's the big three. Fundamentally, they're all the same. They're all going to have servers. They're all going to have networks. They're all going to have security. They're going to, they're just going to, the only difference between the three are the naming conventions and the depth of service that they offer. Some companies, such as like a Microsoft, will go but so deep into uh, security versus an AWS will. AWS will have like 1,000 security resources for security, while Microsoft may condense theirs down to like 6 items, all leading to Active Directory, which just changed to, they just made a name change. I forget the name of it, but um, I think it's Microsoft Entry or something like that, Entry ID. But anyway, they all offer various things. I always give a rule of thumb this: if you're a private company and you're looking to, and you have if you're a private enterprise and you're looking to optimize your infrastructure, your data, your technology infrastructure, and you're looking for a cloud platform, I always say AWS. And and also for newbies, freshers getting in who want to work for those private enterprise companies, go to AWS. They're the most tenured cloud platform. They've been around the longest. They've been doing this the longest. And most importantly, they have the infrastructure set up of data centers globally across different regions and having already met different governance rules of those countries. That will support any enterprise at enterprise level. Um, but it is complex. So, you need to have seasoned engineers working on your stack. if you're going to work with the federal government, especially here in the states, working with the federal government or the state government, you need to go to Azure. Azure just has some of the biggest military contracts around the world. That's just one of the advantages Microsoft was able to conquer. Um, just the earliest of those three, and do the best at. They branded themselves very well at being allies of military companies when it comes to cloud infrastructure and cloud governance. And most governments are using Active Directory anyway, so it's an easy transition for them to go into cloud. So if you want to work for the government or you want to work on government contracts, primarily, definitely consider Azure. And then last but not least, is Google Cloud. Google Cloud is mostly for, I would say, always startups or smaller businesses that have flexibility to try new things. Um, it's a lot more simple than the previous two cloud platforms, but it's just as secure, and it's just as optimized, available. In fact, one could argue that due to Google search engine having built out its physical infrastructure globally, they have like the biggest global footprint network around the world. Their cloud platform runs on the backbone of that. So that's why I would say for like startups and people, newbies and freshers and people who are kind of adventurous, to get into Google Cloud. And then fourthly, you have IBM who's coming into the market as well. They've had an extraordinary uh, year for at least the past 3-4 quarters. They've definitely outperformed their sales expectations and profit margins. So they're becoming a competitor to the big three clouds as well. So IBM, it's a monolithic American company, but they're going to be around as well. So if you want to specialize in dealing with IBM cloud, that's not a bad investment as well. Plus, you want to kind of catch them early while they're still young and growing and become a SME of IBM cloud. Therefore, when the bigger companies do adapt their technology, you have the advantage, going forward. So all of them offer all types of data encryption. They all offer great data transfer speed service. Again, you just got to get familiar with the verbiage of the name usage. They're different. And you just have to get familiar with the depth of service that they go into data transfer. But that's primarily it. Everything else is fundamentally the same. Once you want to learn one cloud platform, it's a lot easier for you to learn the other because you're going to learn, oh, they're all the same. They all do IAM. They all do, data. They all will transfer a terabyte of data from on-premise to the cloud, So it's just learning that the name difference and the depth of service. So hopefully that answers your question.
Yeah, yeah, absolutely. So, because I came across two terminologies. One is
Mhm.
edge computing, and the second one is services computing. So, if I
Yeah.
go with the first, the rise of edge computing and IoT devices is fascinating now. Now, how do cloud engineers make data integrations and the whole thing seamless across distributed environments?
Yeah, to be honest with you, I haven't done much work with IoT. Um, I do know of some IoT engineers. I do know that they use there's a messaging queue service that's used in Google Cloud. AWS has something similar as well, SQS, I believe. But it's also a messaging service. So they basically what they do is you have IoT devices, which is Internet of Things devices set up, and it might be something in the home like a refrigerator, or it might be something like a microwave that has Wi-Fi capabilities, and it picks up on data on changes within the environment, whether you're implementing new updates to the device or it's receiving information to send off to the power company or whoever's in charge of the device. Um, and the process is basically those batches of information is picked up by like a simple queue messenger service in the cloud, and is transferred through some type of data server, some type of it's streaming data server. So in Google Cloud would be BigQuery. Off the top of my head, I don't know what it is in AWS and Azure, but it's picked up by these these big data servers, and used for real time streaming, and process to do whatever with. So if it's to process new orders or send updates to the manager for how the device is doing, what have you. That's usually what the process is. It's a pretty simple process. I've never done it. When I was training for my architect certification, it was one of the modules that we had to go over. But yeah, it's pretty cool actually. And yeah, if you have an IoT device based company, it's something you definitely want to look into. It's a growing niche. It's a growing field where it's going to be in higher demand the more that, because everything everything in our society is becoming more and more technology uh aligned. Whereas things were probably 10, 20 years ago weren't aligned with your Wi-Fi in your home. More and more things are being able to be connected to your Wi-Fi, and that's all connected by Internet of Things. So yeah, that's what I would say for that. Um, but yeah, if you're working with a cloud provider, just look up how to implement IoT things for that specific environment, and it'll walk you through it. It's pretty simple. Once you figure it out. But that, and then serverless. See, serverless, which is interesting conversation. There's a lot of talk about that on LinkedIn now, and especially AWS put out this report where they found out basically one company was going serverless and using containers, and found out that they could save more money using monolithic servers, which are basically stand-up cloud servers, EC2s, what have you. Um, and the thing about serverless, everybody doesn't need to go serverless. If you don't have if you're not getting the kind of traffic on a daily basis to make sense of having a containerized environment or serverless environment. And with serverless, we're talking about Lambda and AWS, and we're talking about um, I think it's functions in Google Cloud. I forget what it is in Azure off the top of my head. But you have to having a serverless environment basically means that you do have servers, but these servers are ephemeral. So they they start up and shut down, and they only work to compute a simple task. That's all the servers are made for, just to compute. So if you have some data that you're putting in, trying to send over to the cloud or update to your large data server, and it grabs the data from somewhere, I don't know, and there's an in between serverless function that creates a server to process this data. Soon the data is processed, the server terminates itself. And so that's like a serverless setup that a company will have or somebody will have. The only process, so they're really cool, because you don't have to, unlike monolithic servers, us as cloud engineers, we don't have to manage them. So we don't have to worry about version updates. We don't have to like we don't have to worry about certain um just all type of tasks that come with networking privileges. We don't have to worry about so much when it comes to serverless computing. The only thing about it is serverless sneaks up on you in pricing, because it's so much, the upfront costs are so much cheaper than a monolithic server. It's a very appealing. But the thing about it is, most companies don't know how much data that they're processing or computing that they're processing within a given amount of time. Cloud is still relatively new. There's no body around that really that a company could pay enough. There's not enough people that companies could pay enough that could be able to measure, well, this is how much data you're using over time, and this is how much exactly it's going to cost you. Especially not knowing how the consumer behavior is always going to alter and change. So I say all that to say, like, you'll think that a serverless option is costing you 0.28 cents uh per compute, and you're like, oh, that's not much at all. We only have but so much traffic that hits their server. Yeah, until you find out that, like, you had a holiday or something come up, or it just regular maintenance things, like things that aren't even affecting the business but still have to be computed. And your monolithic server may cost you anywhere from 10,000 to 20 a month, which okay, you understand this. But this serverless technology by the end of the year could cost you like 20 million, $30 million. You're like, what do we process? Like, how much of that was actual business? So that's the difference between the two. And serverless, again, it's fun, it's new. If you know Kubernetes or get into Kubernetes, you're going to do very well. It's going to be always be around as long as I see it. It works across every cloud provider, as is open source, and every cloud provider has their own version of Kubernetes. But containerization and serverless technology can be costly sneaky on you. So you have to always look at your structure and see, does it make sense for us to, just because it's cool and new technology, to make a monolithic server serverless? You have to ask yourself, like, some things just need to stay around, um, for the time being. Without, you don't have to be on the edge. Every part of your infrastructure stack doesn't need to be on the edge computer. It needs to be sensible, and it needs to be cost efficient. So that'd be my answer.
Yeah. So understand what serverless computing is providing, because before you actually put it up into your system, right? So yeah. And Democus, as a cloud tech advocate,
Hmm.
what trends do you think we will see in the convergence of data science and cloud computing in the near future?
Yeah, so it's interesting, man. I had this meeting with Google Bard, which is their AI service. I have this thing about when it comes to this. So AI is hot, and um, people are trying to figure out if it's hype tech or not. Uh, the thing about it is, so especially when it comes to data engineering is just going to continue to grow. It's going to continue to grow in value. Why? Because data is invaluable. Companies pay billions of dollars a year for data. And this is why data engineers should never sell themselves so short when it comes to negotiating their contracts for work. Because the thing about it is, a company can use one piece of data about a customer and be able to sell several different services and products to them, um, and all just off one piece of data. So imagine having thousands of pieces of data on a customer. You can sell to them all day. You can sell to their kids, their grandkids, except. So don't ever undervalue yourself as a data engineer, um, uh, because the data is king right now. Data is the new gold. Um, I say all that to say, uh, so ML modeling is becoming hot, and due to AI. The thing about it, though, is, from my personal take, is that it's due to the a mass amount of uncontrolled data. So I always think of data like wild horses. It's something that I don't foresee us in the future being able to get a hold of, because you can never really get a hold of a human being who's changing every moment. And you have billions of us changing at every moment for various reasons and circumstances. And all of that is data. And the goal of a ML library is to have the data available to the person that's searching for a certain output. And the problem with that is they'll never be able to have enough current data. Especially most companies, it costs too much money to train your ML library to be able to produce. To be able to produce the content and deliver the output that's available, let alone current content as an output that's available. So I say all that to say that if you're a data engineer, get into ML creation. Start learning how to create an ML library for a company. Because here's what these big AI companies have found out. They thought that they would come to the market, and they were going to take over these search engines as a public search engine, and the average consumer was going to use them versus the traditional search engine. They found out to be wrong. So what they're trying to do now is pivot to private organizations to create their own ML libraries within their private organizations for both their clients and their customers, or their clients and their internal use of the organization. So, like, you go into a company and you all have your own internal words and lingos and abbreviations, and you're searching for tasks, or you're searching for documents, or you're searching through repos for specific things. That ML, if you have an ML library set up within your company, it'll spit out exactly where it is, what it is, blah 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 blah, without you having to search hours through documentation, or, or spend hours in the Slack channel asking other engineers to ask another engineer. But the thing about what these companies are doing, they're selling they've created these templates of containers of ML libraries. So it doesn't have the data of a company's doesn't have the company's data in the ML library, but it has the framework, and all the company has to do is train their people to input the data so it can spit out the right. They have to train their own library. It's like getting a dog. We have the whole dog set up, a cage, and the dog itself, and the little name tag and all that. You just have to train the dog to be fitting for your family. So that's what these companies, big AI companies, are doing with these ML libraries. They're selling them as containers to private organizations, and they're hoping to make profits off of that and uh, uh, build a business, a successful empire off of that. Because going to the public has shown them that the public just doesn't want it right now at the moment. But they got to make money, because investors are like, all right, we need to start seeing some returns. So they're like, okay, well, we're going to pivot to private. And I say all that to say, if you're a data engineer, start with a small project and build an ML library for a small project, for like yourself, either even if it's like it represents a little chat group with your friends or your family or whatever, and it's internal information, but you all can put something into this chat box and it spits out, oh yeah, remember Donna talked about this day, da, da, da. you know that's your own little ML, and present that as projects to companies that you interview for, or for companies that you want to partner with, or however. That is going to prove that you are coming in knowing how to configure the ML box containers that they're given. And that's going to show tremendous value, because you all are going to be hot. They're going, and they need to pay you top dollar. To be honest with you, because that's an invaluable skill right now. It's going to be an invaluable skill for at least a decade or two. So data engineers aren't going anywhere, and that I would say on a trending thing right now. That's the thing right now, because the AI, it's been proven time after time after again, it can't write itself. It can't write itself well, and the software is it's too clunky. It's too clunky, and again, it takes so much money to train it. Most companies just can't afford it. Most companies don't even know if they're it's wild. So like, even as engineers, when we debug a task, like we've tried using these different AI companies software to do it, and it's just not, it comes back and it doesn't work for various reasons that we know why it doesn't work. And the thing about this AI tool is where it doesn't know that the documentation that it's pulling from, if it's right, if it's current, if it's up to date, so you can't rely on it. You still have to have skills. So I said it to say that, like, don't worry about, your job is not going anywhere as an engineer. If anything, these things are going to be your companion, who you're going to have to train up and work alongside with, because until these companies wake up and be like, realize that, okay, AI it might be a customer communicator replacement thing. Okay, cool, for or handle little administration tasks, but to expect it to carry any heavy loading engineering responsibilities is ridiculous. Like, so we're so far from that. We have to keep in mind, most countries and most places in the world are rural. They don't have the technology capacity, and we don't have enough engineers even in the market space who can do the work. So it's like we read so much forward thinking content, but we don't understand where we currently are in the world yet. So yeah, it's one of those things. It's like I'm I have a lot of respect, and I see a lot of the value for data engineers continuing to grow. I just want data engineers themselves to uphold themselves to the value that they're contributing to a company. Don't let them underplay you or underpay you, or underserve you, because your value is going to grow. Data is the most invaluable thing. So
Yep, got it, Demicus. So can't relate more, because the biggest example There's ChatGPT and Bard. Uh, I don't know how much amount of time and money they have spent in training those big models. You know, yeah. So it can give you answers to almost anything and everything you put in it, right?
Yeah.
So
Yeah.
yeah, and
Yeah. And even if you look at Chat GPT, it'll tell you like, hey, it's pulling data from 2021. You know,
right.
think about that. How much has changed? So it's like, come on. You're gonna build your infrastructure stack or your data stack off of, man. You'll get fired pulling old data. So anyway,
Yeah, and as well, they have given you the option, to integrate the APIs, and you can fine tune it as well, right? So anything and everything is there for you to use, right? Yeah,
yeah, yeah.
got it. So, you probably have encountered, some exciting success stories or, use cases where, cloud engineering played a significant role in enabling, successful data science initiatives, if you have any.
I would say, I mean, data. I've seen data engineer. If we're talking about successes of data engineers themselves, I've seen people go from. Um, I've seen one woman in particular go from working in the grocery store, not having any tech background, to picking up data engineering, and she studied for about a year, mostly self study. She did some boot camps here and there as well. Studied for a year and got her first data engineering role just this year. So even in the midst of all the layoffs that's just being hyped up and stuff, people are and I'm seeing data engineers, get jobs weekly on my timeline. So it's definitely one of those things where it's not something you have to have a data scientist background to be able to get into. You can pick it up and learn. A human can pick up and learn just about anything if you give them enough time and you give them some good resources. And that's the same thing I've seen with data engineering. And data engineers have to keep in mind that you know they exist. We exist because their work exists. These training modules that we utilize all comes off of accurate data models that they're utilizing. Of learning what works and what doesn't work for their students or their clients, or however, and what type of training people most receptive to. That's all data. So yeah, I mean, I've seen that happen every week. There's somebody in different aspects of data engineering, getting a job, and they're starting small. They're going out learning SQL. They're going out and learning various ML or do even starting off data analytics, like small things, monitorization, being able to set up monitoring. So, it's not something that a person has to go in and say, I need to know calculus and know the most high level of math off the rip. Have some deep college background. You can, if you do, that's great for you. But many people don't, just haven't went that route, and they're still able to get into the field. Just start. Start somewhere. Start small, as I always say, and what I've seen, and continue to build your opportunities from starting small is what I would always say. And yeah, I'm seeing data engineers gain jobs at uh, Fortune 500 companies as well as small startups. And sometimes that does mean that you're gonna, while you're working up to your big first opportunity, you might have to do some free work for somebody. You might say, hey, well, you all got some data. I can process your data for you. I can show you how to ingest it smoother. I can show you how to ingest it safely, etc. And there's all type of startups in cities across the entire world that are looking for help in any way that they can receive it. So if that means donating a month or two to your time and then adding that experience to your resume, as project experience, as relative experience, it gives you the ultimate advantage. So yeah, it's happening every week, and like I said, just never downplay your value as being a data engineer.
Got it, Demecos. So let's assume a data scientist who is
Hmm.
interested in cloud engineering. Okay,
Hmm.
and as we know, you have your own course revolving around cloud engineering. And
Yeah.
if you talk about the motivation behind starting the course, and what advice would you give when you are starting with cloud engineering?
Yeah, I mean, well, I became a cloud engineer in 2018 after getting laid off from both, well, getting fired from both Uber and Lyft. And I picked up, I just trained. I got my certifications. I helped. I got my AWS practitioner certification, and I helped a friend of mine who was running a blog site. I helped her build her website on AWS. Again, that's offering free work because I'm like, hey, to help my experience. And probably a week later, after getting my cert and having that experience on my resume, I ended up accepting my first cloud engineering role. Um, and it changed my life, from there on out. I would say anybody that's looking to transfer from cloud, excuse me, from cloud to data is that to understand that um, no one's your biggest obstacle in becoming a cloud engineer is going to be fear. It's not going to be the work is too complex. It's not going to be learning the different. It's not going to be expectations an employer has of you. It's always going to boil down to your fear of joining a boot camp because you don't see the outcome. You don't think the outcome is going to serve you. It's going to be your fear of not paying for a certification because you don't think they're going to hire somebody who doesn't have any technical background experience. Fear is going to always be the main obstacle in your way that you're going to have to learn to have a uh, you're going to have a healthy you're going to have a healthy management of it. You're going to be able to manage that fear, because it does serve us good in some ways, but in most of the time, it's always in a way. So you're going to have to just be comfortable knowing that where the fear exists is usually where you need to be able to summon up instant courage to be able to get what's on the other side of that fear. Because usually your fear is keeping your biggest life changing goals from you. So I would say that it's managing your fear and then investing not just monetary wise, but your time. Like you're going to have to, the reason I created my boot camp, my cloud engineering boot camp, was because when I was coming up, there weren't any cloud engineering boot camps, especially there weren't even any available in my entire region of the US. And there weren't many people talking about it at all. Even AWS itself had a very rustic training course that was mostly animated training course where the cartoons would stop and freeze. Like it was very bad. It was bad audio, and it wasn't all on the certification test. So I came up very hard and in the dark and having to figure it out myself. And I told myself, once I get on and become a cloud engineer, I'm going to help. I'm going to help others not have to endure what I had to endure. So that's what this boot camp I created is for, and that's what I want others to know, that you have infinite amount of resources out there. Not just my boot camp, you got other boot camps out there. You got other training. These cloud vendors themselves have started to create wonderful training materials, not only just for training for the certification, but hands-on labs. And that's one thing I want to harpen on, and I always try to harpen on my platform, is trying to say that it's projects and certifications, not projects versus certifications. All right. Your certs are going to get you in the door past hiring managers because they don't do the job. They don't really know what it ends, and they just know the paper that they're given of expectations. They just know the qualifications. Your certs are going to get you past that person. Your projects is going to get you past the hiring managers and the people who actually do the job, because they need to be able to know that, okay, this person has touched these cloud resources before and know what they do in different aspects. So so in saying that, my last one would be going back to, you don't have to know everything to be a cloud engineer. You don't have to know everything about cloud to be a cloud engineer. There's so many facets to being a cloud engineer. There's so many different roles that it's labeled as. You just need to start somewhere. As I always say, find a camp, find a guide, find a book, pick up something, do something, break something in the cloud. Like, do start somewhere, and you can make this journey and become a cloud engineer. I always say estimate time between 6 months to 1 year. And that's being able to change your life. Because once you get the hardest you're going to ever work as a cloud engineer is becoming a cloud engineer.
Got it. Got it. Great motivation, Demetrius.
Yeah.
So uh, we'll switch gears over here a bit. Let's debunk some myths or misconceptions about cloud engineering, and
Let's do it.
maybe its intersection with data-driven models. What are some common misconceptions that you have encountered?
Misconceptions is, especially here in the States, is that you're going to make six figures as a cloud engineer your first role. That's false. Okay. You're not going. I made 60,000 coming in my first role, and to me that was life changing money because I never made that much money before. And then once I started doing the job, I was like, man, this is easy. This is sweet. Why did I think of this a long time ago? I mean, since then I have made six figures, but it's a journey to six figures, and six figures shouldn't be your goal. Your goal should become becoming more skilled, because once you become skilled, you're going to always get paid. You're going to get paid in so many different ways than just from an employer. People are going to pay you for advice. Like I've had people just pay me for consultations. I've had companies just hire me to do presentations. Like your skill is going to take you so much further than the actual job payment. So that's a myth. You're gonna come in probably making you're gonna make above average for those people in whatever country you're gonna make above average. Um, but it's not going to be like the highest 10%, 20%, but yeah, eventually you can get there one day, depending on if that's your goal or not. But though these skills going to open you up to a whole new world. You're going to meet people around the world, me meeting people like you. Like it's invaluable how looking beyond just six figures is going to change your life and working in tech, especially specifically cloud engineer or data engineer. So yeah, that's a myth that I want to debunk. You're not coming in becoming a millionaire or a high six figure person off the top. No.
So run after the skills first rather than the figures, right?
Yes.
Yeah, yeah.
Yes.
Got it. Democus, thanks for making time on a Sunday. And
No problem.
so, we'll love to continue the conversation sometime. And yeah,
Yeah.
thanks for coming.
Oh man, thank you, man. I appreciate you for staying up late for me. I know you got to get to bed, man. This is a great platform. I think you're doing a wonderful thing, man. You are going to help so many more people than you realize, man, across the globe. Please continue this. We need more of these type of dialogues, man. More of these type of connections, man. So any way I can support you going forward, just let me know. All right.
Absolutely. Looking forward to scale it even, further. Yeah.
All right, brother. You have a great one, man. Be great.